Warning, the video you're about to watch contains mathematics at the level of college algebra and trigonometry. All material has an assumed prerequisite of both Algebra 1, which is elementary algebra, and Algebra 2, which is intermediate algebra. While some prerequisite topics are reviewed briefly, a more thorough review of these entrance topics can be found by searching the web.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcome.
Hello, my name is Roy Simpson, professor of mathematics at Cosumnes River College in Sacramento, California. In this video, we're going to continue our discussion about rational functions. You should have watched my brief review of rational functions video already. That's really kind of the setup for everything we're going to discuss here. And I'm intending for these videos to be a little bit shorter, snippets of ideas rather than big, long 2-hour videos that are lectures. So here's a snippet: finding domains of rational functions. So we know that functions generally have domain issues when you try to plug something in and it just breaks the world, right? So for example, natural logarithms, they're completely broken if you try to plug in 0 or negative numbers. If you think about a fraction breaks if you try to plug in 0 into its, or I'm sorry, if your denominator turns into 0. Not that if you try to plug in 0, but if your denominator can become 0. So how do you determine the domain in general for a rational function? You should be able to, or you should have already done this in your intermediate algebra course, but let's just go ahead and review that topic here. Given a rational function like this, you really need to first factor denominators. So to find the domain, specifically the domain, I'm not talking vertical asymptotes here. I'm just talking domain. Domain and vertical asymptotes are completely different ideas. So I wrote it up above. Domain restrictions, things that would cause division by 0, and vertical asymptotes are related, don't get me wrong, but they're not exactly the same, because your domain restrictions could be much larger than the actual set of vertical asymptotes. And this is a good example showcasing that. So let's start by factoring the denominator here, because that's all you really have to worry about with domain. So I'm going to leave the numerator completely unfactored. Well, okay, it's not completely unfactored because somebody was kind enough to at least factor it a little bit. But those two trinomials can be factored even further, but we're not going to bother with it. In the denominator, that's a difference of squares, x minus 4 and x plus 4. And that's a sum of cubes, x plus 2 times the quantity x squared minus 2x plus 4. So you'll notice that in my videos, I do not actually talk about the review of, oh, you should know how to do a sum of cubes like that. There's a video for that. So you can look through my video sets to review sums and differences of cubes if you need to. So notice that we would have division by 0 if x were equal to 4, if x were equal to negative 4, and x were equal to negative 2. This last trinomial right here, by the way, is called a prime trinomial or a prime polynomial. And prime polynomials, generally speaking, are not factorable. Well, okay, they're not factorable. I was gonna say, they're just not factorable. But if you really want to know, hey, could that ever become 0, just set it equal to 0 and find out. If you set x squared minus 2x plus 4 equal to 0, well, it's not going to factor easily, at least. So let's go ahead and use the quadratic formula. That gives us 2 plus or minus the square root of 4 minus 4ac, right? Now, if you take a look at that, I don't have to go very far to see that this is going to be a negative 12 within that radical. So 4 minus 16, right? And downstairs is 2. Since that is not a real number, so not real, I don't have to worry about my function or that denominator, that factor of the denominator ever becoming 0. It just won't, because it will only become 0 if I allow for non-real numbers. The truth is, whenever you graph a function, you're only graphing on the real number system or on the real number line. So there's no reason to worry about that. All right, so let's talk about that domain. I know that x cannot be, in fact, I'll write this in red since I'm saying what x can't be. X cannot be 4, x cannot be -4, and x cannot be -2. Most people, myself included, do not want these answers written this way. You need to write your answers using interval notation. So you will go ahead and say, okay, the domain, let me actually write it here, domain. There's a couple ways you could actually do it. I'm going to say x is allowed to be in the interval. Well, I can go from -infinity all the way up to the lowest of those three numbers, which is -4. I'm going to skip over -4, and I'm going to let it climb a little bit till it gets the second highest number. And then I skip over that second highest number, and I'm going to let it climb even further until it gets to the third highest number. And I'll skip over that third highest number and let it continue on to infinity. And that's how you would state the domain of this function in interval notation. You should know interval notation intimately from all your algebra work prior. So if you need a review of that, I would definitely look online, maybe Khan Academy or something like that, because they usually have those elementary topics there. One thing also I should note is that some people will say, some professors will look at this and say, you didn't factor the numerator. There's some very special things happening in that numerator. I 100% agree with you. There are some very special things happening in that numerator. However, this question is not asking for that. This question is just asking for you to find the domain of the rational function. And the domain is always restricted when your denominator becomes 0. So all I'm doing here is factoring that denominator and finding out what would cause division by 0. And I'm throwing those out of the domain. That's it. So really, that's how you would find the domain. We're going to play with this function a little bit more in a future video. So for those who are looking at that numerator and it's like bothering them, don't worry, we'll get to that. All right, so that's it actually for this video. That's how you find domains of rational functions.
It's the system of equations. We must deal with them all at once. Always looking for solutions. Positive outlook overcomes obstacles getting in our way, cause affects more than we can sometimes see. Things for what they are and work together until you feel at peace. Says, listen close, don't talk too much, that isn't kosher. You may really hurt inside. It doesn't justify you to speak too loud and cry. Don't whine, just